So we're back, and in this video we're going to go through logical implications or the rules of inference. Well, we're really going to go through the rules of inference in the next video, but right now we're just going to go through this little formula or statement that we have here. Now, you can see right away that this is pretty much an implication. We have our P and we have our Q's. Now you can see that I've split up our P's into little components numbered from 1, 2, 3, all the way to n. Now, there are some constraints that we have to follow in this case. One of them is being that n must be positive. This n must be positive, but that's kind of intuitive since we're counting 1, 2, 3. It has to go up, not down, right? And also, when P1, P2, P3, all the way to Pn is true, then Q is true. So when all of this, when P1, P2, P3, all the way to Pn, when every one of these components are true, then Q is also true. Now, if any one of P1, P2, P3, all the way to Pn is false, then this hypothesis is false. And the implication is true regardless of Q. So you can really see that in all these components here. So just imagine that if you had single one of these P's, these components, be true except for one, which turns out to be false, then you'd have something like 1, 1 and 1 and 1 and 1 and 0. No matter how many ones there are, this statement will give you a 0. It will give you false. And remember in one of my last videos how I taught you implications. When 0 implies 0, that whole statement, that whole implication is true. 0 implies 1 is also true. The only case in which this implication is false is when 1 implies 0. That will give you a false implication. So now that that's over with, now here I have some primitive statements and some premises. P is Ted studies, Q is Ted plays basketball or baseball, and R is Ted passes math. So these are all the let statements. And the premises are as follows. P1 is if Ted studies, then he passes math. Now P2 is if Ted doesn't play baseball, he'll study. And P3 is Ted passes math. So what I want you to do is I just want you to copy this down on a piece of paper because you're going to need to refer to it if you're following along with the example. So let's go on to the example. And this is what we want to determine. We want to determine if P1 and P2 and P3 implies Q is valid. So what we do is we rewrite our P1 statement in the form of P and R. So P1 is if Ted studies, then he passes math. So we're going to have if Ted studies, so that's P from here, and then he passes math. So if Ted studies, then he passes math. So that's pretty much an implication. So we get P implies R. And going the wrong way again. So that's what we got for P1, and that's the same thing that I did for P2 and P3. So that you could do that by yourself. I'm not going to do it with you. But what I want to do now is, since we rewrote our statements, our sentences into these into its symbolized form, I want to represent this statement with these new symbolic sentences that we made from those sentences. So what I want to do is I want to substitute P1 for P1, P2 for P2, and P3 for P3. So what I end up with is P implies R, this would be P1, and negated Q implies P, that's P2, and negated R. Aw, crap. P and negated R. And this will all imply Q. And this bracket is not supposed to be here. I hate this application sometimes. you undo a lot of fucking things you wrote, and when you erase, it erases everything. And sorry for cussing, but I'm that kind of person. So that's what we have here, and that's the statement that we have here. Now here I have this table, and it's blank right now. So what I want you to do is fill it in, because right now I'm gonna end this video. So I want you to fill in this whole table and come back in the next video to check your answers, to check if you got it right, and we'll pick it off in the next video. Other than that, please rate, comment, subscribe, and I'll see you guys in the next